Now, we've been talking about point-slope form of a linear equation, and we were also talking about writing the equation of a line that's parallel to some given line and passes through a given point. Before we move on from that, I do want to make a couple of quick comments to help you out. One is that often as math teachers, when we're introducing a new concept, we will use examples that have simple numbers in them. So I've used lots of whole numbers. My slope is a fraction, but it's a simple fraction, 1/2. It's nothing too crazy or complicated. But oftentimes in real life, this is comment 2, that's not how it is at all. Numbers are complicated. So there can be crazy decimals. You can have irrational numbers. You can have awful, ugly fractions. And it's important that you're able to identify, say, the form of the equation you're looking at, or to write an equation in a particular form, even if the numbers aren't simple or pretty, or you can't look at a graph. So just to toss this out, say I had, I'm going to make this up off the top of my head, a slope of, 0.295, and our point being, 3.96 comma 2.11, right? Those are like not exactly simple, pretty whole numbers. They're decimals. And I could write an equation for the line that has this slope and goes through this point. It's simply y equals our slope, 0.295, x minus our x-coordinate, 3.96, plus our y-coordinate, 2.11. There we go. And if I wanted to, say, find out what's the y-coordinate that goes with a given x-coordinate on this line, I would just plug in that number for x. Maybe it's a terrible number like 3.22 or something. You just have to get out your calculator and do the math. Minus 3.96 times 0.295 plus 2.11, output of y. If I knew the y-coordinate, I'd have to just put it over here, and then I'd end up having to solve the equation to figure out what the x is that goes with it. So, might not be a pretty thing to do. Another thing about this equation here, with the subtraction in the middle, I do one more example because I haven't talked about this, and this does come up. Say I had a slope of, we're going to go back to simple numbers again, say 3. And say my point was -2, 5. So I write in my equation, y equals 3x minus, but my x-coordinate is -2. -2 plus 5. And so I have this minus a -2, which we would rewrite as 3x plus 2 plus 5. So if you see a point slope equation that has a plus in the middle, it means that the point that we picked had an x-coordinate that was negative. And we could do the same thing if we had, say, a negative y-coordinate. So if I had slope was, 11/3, and our point was 2, -6, so we have y equals our slope, 11/3, x minus our x-coordinate, and then it'd be plus a -6, but we don't write it as plus -6, we'd write it as -6, so it'd be y equals 11/3, x minus 2 minus 6. Okay. So again, two things, your takeaways from here is, one, when you're doing this point slope equation, or any equation for that matter that involves lines, it could very well have ugly numbers in it. Maybe these are, as this is an example with decimals, but it could be ugly fractions, irrational numbers like square root of 3 or something like that. The numbers don't have to be pretty, and you need to be able to look at an equation like this and go, oh, you know what? That's slope, that's x-coordinate, that's y-coordinate. And you need to be able to work with an equation like this. Plug in an x, output a y. Plug in a y, solve for x. So good to practice with those. And the other point was that sometimes if we're dealing with point-slope equation and points that have, say, x and y coordinates that are negative, perhaps, like here's an x coordinate that's negative, then it's minus a negative, which turns out to be plus. Or in the case where the y coordinate is negative, it's plus a negative, which turns out to be minus. So that's a couple of pointers on working with point-slope equations that have not quite so simple numbers in them.